Everything's fine. As far as I know. Okay, the first thing we're going to do is look at some different things about how to use a calculator. Because from now on, you can use a calculator on all your tests and things. And we have different types of calculators. This one I've had for like, I don't know, 20 years or so,
Wow.
something like that, so it's old, but it works most of the time. But there's a few things I wanted to let you know about, and that is, if you are, adding, subtracting, multiplying, or dividing, pretty much everybody knows how to do that. But if you've got a problem like this, 72 divided into 12768, something like this. Okay, some people don't know which one to put in the calculator first, okay? But it's always this one divided by that one. So you'd put in 12768 divided by 72 equals, okay? Now, if you had to have your answer with a fraction, or a remainder, you could get most of it, and then if you know that 0.3333 is a third, then you would have that, or like remainder 1. But you may need to do it by hand to make sure that you have it right. Okay, but anyway, it's this one divided by that one. So you always put in that number first. 68 divided by 72 equals. Okay. Now, another thing, you can actually do fractions on your calculator. Okay. If I have something like 1/5 plus 2/3, you can say 1 ABC, this is the ABC button, and you'll have to find it on your calculator. ABC 5 plus 2 ABC 3 equals, okay? And so, now I'm not, I don't trust the calculator as much as I do myself, so we'll check to make sure. 5 going to 15 3 times. 3 times 1 is 3. 3 going to 15. 5 times 5 times 2 is 10. Add them together, and you get 13/15. And you see that little thing right there? That shows you that that is a fraction, 13/15. Okay, there's kind of a glare there now. I think you can see it okay. So try a problem on your test, a fraction problem, and see if you come out with the right answer by using that ABC button. It's a A and then a B and a C, and you'll have to find it on your calculator.
I don't think mine has it.
Okay.
Simple.
Okay. Alright. Oh yeah, okay, yeah, yours probably does it. If it's a scientific calculator, which means it does everything the way that you would in algebra, you can see, did yours work? Okay, alright. Let me look at yours too. See, I used to have a bunch of these and I would pass them out and we'd all have the same kind, but I have like 5 left.
I don't think you would have it on there anyway.
Yeah. Oh, it's just on your phone. Yeah, probably not. Okay. Anyway, if you do, how about yours?
I don't think mine does either.
Okay.
There's something on there wrong.
Yours should, but it'll be a different looking thing.
Maybe you go on with
booklet came with it, I'm sure it says
So,
on there.
I have it on there somewhere.
I'll play with it and figure it out.
Okay. All right, let's see. And this, it's not essential, you know, that you have this kind, but it can help you. Let me show you one like this. If you have like 1 2/3 plus 3 1/4, okay, you know all the different steps you have to do on that. But let's see, you have to do like 1 ABC 2 ABC 3 plus 3 ABC 1 ABC 4 equals, and so it comes out to 4 11/12. That one. But you have to do that ABC button in between each one of them. Okay. Now, I would never do that. Like on a test or quiz. It's way too many steps and takes too much too much time. I would just do it out by hand. But if you wanted to check yourself, you know, that's a good thing to do. Okay, another button that you might need to know about, it's like if you were going to take a number raised to the third power, like a 3 raised to the third power. Okay, on this particular one, let's see, here's squared. If you just wanted to square something, you could do that. But this would be the one that you would use as y raised to the x. So I would use 3 raised to the x 3 equals, which is 3 times 3 times 3 is what that means. But it's, the button is a y to the x that you would put in there. So you would do a 3 y to the x 3, and that would give you the answer to that. If you, later on we'll do some problems where you need pi, okay? And this particular one is right here. If you need to get up to something that's over a key, you hit second, and then hit that, and that's your pi button, okay? And like I said, if you just want to square something, there it is. If you want to take the square root of something, it's up on top. So if you want to take the square root of 16, that means what number times itself would give you a 16? And that would be a 4. 4 times 4 is 16. But you can push in 16 raised to the second power, see, and that would give you the 4. And when we get into each one of these things, you know, if I can remember it, I'll show you, you know, how to do it on
As
your
far as
calculator.
pi goes, I don't know if anybody in here is taking Greek, but the symbols right there is the pi symbol for Greek.
Right, exactly. And there's a lot of different math symbols like theta and things like this you use, and even the X, you know, what do you call that?
C is how it's pronounced, X-I.
Okay, alright. And so a lot of different math symbols, like there's the, that one up there, I don't remember what that is either, but that one right there, a lot of times you use that one.
Lambda.
Right. And so there are some similarities and things that you need to use. But anyway, so if you have a calculator, then we can use that on different problems and see how it works out. Okay, now we're going to start into chapter 1 in your book. And chapter 1 is critical thinking skills. We've already done a little bit of this with our reading problems that we've had. But anyway, so we have like chapter 1, critical thinking skills. And we use different types of reasoning every day in life. And the first type that they're going to talk about is inductive reasoning. Okay? And with inductive reasoning, it uses examples, okay, in order to come up with the answer to something. Now I'm going to, we're going to take some notes on this, okay. So we have inductive reasoning. This is chapter 1. Okay. inductive reasoning involves a decision making a conclusion based on a series of examples. Inductive, it involves a decision making a conclusion based on a series of examples. A single contrary example, that's also called a counterexample, will invalidate it. Okay, in other words, it'll show that it's wrong. Okay. All right, so if you have, our first example is, okay, there are 5 lamps that do not work because of defective bulbs. So you're turning on 5 different lamps. Okay, one of them, and if a lamp doesn't work, you might conclude that it has a defective bulb. But can you think of an example that might be different from that? Okay. If 5 of them all have defective bulbs in them, and the next one you think, well, it's going to have a defective bulb too, but it might not be plugged in. Okay, you see, okay, your reasoning was faulty. You were assuming because all those examples were the same that that one would be defective too, but it wasn't. Okay, let's look at some of them in the book. Okay, it has the product of 2 odd numbers. Number 1, if 2 odd numbers are multiplied together, will the product always be an odd number? Okay, so you just write down some different examples. 1 times 3 is 3, 1 times 5 is 5, 1 times 7 is 7, 1 times 9 is 9, 3 is, okay. All these are odd numbers, and they all come out with odd answers. So you might predict from these examples that any 2 odd numbers multiplied together is going to give you an odd number. Okay. You can guess that that's what it is based on the examples, but you're not completely sure. Okay, now here's another one, example 2. The sum of an odd number and an even number. If you add an odd number and even number together, will the answer be odd or even? Okay, so 4 and 3 is 7, so it's odd. 5 and 12 is 17, it's odd. 9 and 6 is 15, it's odd. 5, okay. So it looks like it's going to be odd. But that is a prediction. We cannot really conclude that that's the answer. But all of these are inductive reasoning based on examples. So what you will have to do is you will look at things and decide whether it is inductive or deductive. If you see a bunch of examples, you'll know that it's going to be inductive. Okay.
Now, how can that actually help?
Okay. We don't worry about that right now. Okay. What happens is in math, if you took geometry in high school, also in science classes, every example or every experiment that you're working with in science is deductive reasoning. Okay. Now, and this whole course is just showing you a little bit of math, of everything. Some of these things at your age you have encountered. Other ones you never use it, won't ever have to use it.
Deductive reasoning would be like having a multiple choice question or a question with multiple choice answers, and then you realize in the first 2 that are obviously not the answer. So that kind of like the same principle.
You're going from one thing to the next. Because of this, then this, and because of that, then this. And you base a conclusion like that. That'll be deductive.
In logic class over at Southeast, we talked about inductive versus deductive reasoning.
Right.
I think if I remember this correctly, inductive is reasoning from a specific to a general. So seeing a specific example and trying to reason, okay, what does this say about the overall principle?
Everything.
Whereas deductive is taking specific examples and then, or general examples, and then reasoning, building off of each other to
To a specific
to a specific
conclusion.
result. And the inductive reasoning is always probability, whereas deductive is matter of fact. So there are these specific possibilities, and it has to be one of these things because it's building off of each other if it's deductive, whereas inductive, it can only reason possibilities. So,
Right.
like you were saying, you know, if you see 5 lamps and they all 5 have a light bulb that's not working, you can have a pretty good probability that the 5th one, you know, is out, but there's also other options. So this is a possibility or probability,
Right.
from my understanding of it.
Right, that's good, because and there are a lot of different things in math that you will use in preaching, things like that.
Yeah,
It's
essentially
like-
interpretation.
Yes.
Hermeneutics.
That's right. Okay, so you will need it. Okay, now next we have deductive. And then it involves making a decision based on previously accepted and proven facts.
It's all you're right and I shake the table at the same time.
Okay, here's an example of this. Okay, you've got all fish can swim. Okay, now that's basically, you know, people believe that. Okay, a shark is a fish.
So, kind of like a form of autonomy.
Therefore, a shark can swim. Okay, so this is pretty much everybody believes that all fish can swim. A shark is a fish, therefore a shark can swim. And this is the way almost every one of the deductive ones are. It starts with this, you add something else, and then because of that, then this. Okay. Now, if you
Syllogism.
Okay, if you look on page 3, it has, okay, deductive reasoning. Okay, well, here it says you usually have a hypothesis or a conjecture, then you have a conclusion, and then, let's see. Let's look over here. All right, let's look at example 6 on the next page. Okay. All right, if you're using deductive reasoning or deduction, you use this to prove conjectures, whether they're true or false. But if you find one example that makes it not true, you know, then it proves the whole thing false. Okay, so if you look at the top of page 5, it says pick a number n, multiply the number by 4. So that's 4n, 4 times n. Add 6 to the product, divide it by 2, okay, and you get 2n plus 3, and then you subtract 3 from the quotient, and you get 2n. Alright, so this example shows that it is twice the original number that you selected. So your conjecture or your guess or your hypothesis is that if you go take a number, multiply it by 4, add 6, divide it by 2, and subtract 3, you're going to end up with twice whatever your original number was. Okay. Now, I'm sure you have seen a lot of those types of things.
I have tried to forgive them for that.
Yes, I know. I never have really cared about those. Most math people do, but I don't care about that stuff. You know? But anyway, okay. Let's another thing that we need to do besides this, so that we'll review. These are some symbols that you will need in math. Okay. Of course, this is an equal sign. Okay. If you put a bar through it, it is not equal. Okay. This is less than. This is greater than. Now, when you were in elementary school, your teacher would tell you something about the alligator is eating the blah, blah, blah. Okay. I look at it as on a number line. Okay. These numbers are the smaller numbers, so it's like that way. The numbers get smaller. This, the numbers get bigger on a number line. Okay. So that's the way I do it. You do it however you want to. And then we have like less than or equal to, or greater than or equal to. We have the two little squiggly lines, which means approximately equal to. And we have one little line, which means not. Okay. We also have, these are called ellipses. Okay. And it means and so on. Or it keeps on going. You know, keeps on going. So, if you know those, then that will
Is that like a little,
help you.
like if you turn a third into a decimal and you put the slash over the 3 to show it keeps on going? Is it kind of like that?
Kind of. It's like if you're doing like this. Okay, so the pattern keeps going the
Gotcha.
same. Okay. All right. Now, here's something else that you might see sometime. Depends on which context that things are in, how you pronounce a word. If you have something like okay.
Invalid and invalid.
Right. Mm-hmm. So this one, you know, is in ill health. And this one is not valid. Okay. All right. You can also use something like this. That could be lead or lead. You could have something like this, which could be a bow in your hair or bow, you know. Okay, so sometimes it depends on how you say it. This is another thing. These are called vanity plates. Okay, if you've ever been riding behind someone in a car and they have all these symbols and letters and you almost wreck trying to figure out what does that mean. You know, if you have like this is like 2 for T and T for 2. Something like that. Here's another one. I see you are the one. Okay. All right. A lot of times people have like, let's see. This is the more normal ones that people have around here, except this would be in Tennessee. It would be here. It would be like this, you know. But I am for UT. Okay. All right. Now, Another thing you might need to know in this section is pattern recognition. Now, you're going to have a bunch of different questions. Some people will be able to figure them out easily. Others, it will take a long time. And but we're going to see some examples. That's 1Z3 W 9 T 27 Q and 81. And you want to know what the next two characters would be. Okay, I'll let you look at that for a minute. Okay, I think some of you already have it. What do you think it'll be here?
I have no clue. I'm just-
Okay, look at the numbers.
Hold on, I think I got this.
I mean, they're all going, or from 3 on, they're all going into 9.
The letters subtract 3 in the cycle from A. The numbers are multiplied by 3 at 3.
Very good. Okay, so this one will be a N, and this one will be a
Okay.
243.
Oh, wait. Sorry.
Okay.
Sorry about that.
Because they were going. Because say on this one, 1 times 3 is 3, 3 times 9 is 27, 3 times 27 is 81, 3 times 81 is 243. And here, like he said, he was going down by 3. Okay, so you have to figure out what that is. So it's N. Okay, here's another one. Yeah, like I said, some you'll be able to get, other ones you won't.
Maybe start eating more carrots.
What will be the next two terms? This one's easier.
1617.
Yep, 1 6 and 1 7. Okay, see that? You're just going up 2, 3, 4, 5, 6, 7. Okay, you'll have a bunch of those. Okay, now, next is arithmetic progression. Okay, the example here is 1, 3, 5, 7, and you might have to give what the next one is. 9, okay. Now, notice you're adding 2 to get from one to the other. Okay, so you're adding 2. So if you add or subtract the same number from each one, it's arithmetic. Okay, now this one, let's say we have 2/3, 1, 4/3, 5/3, and 2.
Just keep going up. 6/3, 7/3, and then 3.
Okay, so if you're adding a third to each one of them, so 2/3 plus a third is 3/3, which is 1. Add a third, that's 1 1/3 or 4/3. Add a third is 5/3. Add a third is 6/3, which is 2. So 2 1/3. How would we write it instead of 2 1/3 though?
7 1/3.
7/3. Good. Okay. So that's the one we're looking for. Okay, what would come next?
It'll do that.
Add a third to it.
8 1/3.
8/3. Okay.
My little brain.
So see, 8/3 would come next. So all you were doing on this one was adding 1/3. Okay. Now, next we have geometric progression. Okay. So the examples on this, you might have 2, 6, 18, 54.
Multiple products of 3.
Right, so you're multiplying the previous number by 3. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So 3 times 54, is that 162? Okay, so you are multiplying or dividing the previous number by some number. Arithmetic progression, you are adding or subtracting something from the previous number. Okay, so you'll have different ones like that you'll have to do. Okay, now let's see. Okay, we're gonna look at some of these together before we do what's in the book. Okay, now the first one it says, after eating lemon chicken for the first time, Ralph comments to his wife, Elaine, that he likes it. Elaine decides to make and serve lemon chicken to Ralph every week. Okay, well, that's kind of stupid, isn't it? Okay, but it says, is this inductive or deductive? Okay,
Inductive.
okay, inductive, good.
So you would have
Okay,
it
so just
52
put an
times
I up there. What?
So you would have it 52 times a year.
Uh-huh, right. So just put an I over there to show that it's inductive. Number 2, when it's cloudy outside, Marshall does not go flying. Marshall is not flying today. Therefore, it must be
That's deductive.
cloudy. Deductive, right. Okay, you can usually tell by the way they word the question. This, then this, therefore this. The results of a survey of 15 homeless men in South Florida indicate that the majority of those interviewed had beards. Using the results of this survey, a newspaper reporter writing a story on the homeless in America states that the majority of homeless men have beards.
Inductive.
Inductive.
One
Okay.
of the things that give that away is the word majority, because talking about a probability or
Uh-huh.
or percentage.
Very good.
Aren't you from Florida too?
No.
I don't know why I was like, but he has a beard.
Right, yeah. And so do you. Okay. Give examples of at least 2 contexts in which the symbol, an asterisk, can be used. Okay, can you think of something? Okay, have you ever seen... Okay.
Is it
Multiply, multiplication, can be used like that. Also, if it's like on a page and you have an asterisk at the end of the page, what does that mean usually? You look like down at the bottom and it tells you footnote thing, yeah. Okay. All right. Next one. The following statement appears on a sign announcing a new lottery game. You must be 18 to play. Interpret the meaning of the statement.
No one under 18 can play.
Right. Okay. Or you must be 18 years old to play. Whatever. Okay. Number 6. Okay. We have this one. Okay, identify the pattern and determine the next iteration. So what should come here?
10 to the 5th power equal 5, 10 to the 5th power equal
Mm-hmm.
100,000.
Okay. Well, we don't have to even do that because see, they didn't. They just said 10 with a little sub down here, and so they put the number in the bottom. So 2, 3, 4, 5. Okay. So that's the one you add to it. Okay. And then number 7 is what you were talking about.
Oh, sorry.
It's all right. Okay, so it's easy to see that these are going 10, 2, 3, 4, so that would be 10 to the 5th. And this one, all you have to do is what? Just add a 0, right?
Bump it right.
Okay, so there we go. Now, number 8, you've got an S over N equals 10 implies 10 decibels. S over N equals 100 implies 20 decibels. S over N equals 1,000 implies 30 decibels. So you'd have S over N equals what? 10,000
You've done it. You got it.
equals 40. Right. Okay. So all you're doing is identifying the pattern here. Okay. And usually when it's a pattern, it is like inductive reasoning. Okay. And number 9. Okay. Look at this one. Okay. You've got 2 points makes it into 2 regions. Okay. So look up here just a minute. See, this is a region and that's a region. If you have 3 points and you make lines, you have 1, 2, 3, 4 regions. If you have 4 points, you have 1, 2, 3, 4, 5, 6, 7, 8. Now, you could draw these things all day, but if you'll look at the numbers, 2 points, 2 regions, 3 points, 4 regions, 4 points, 8 regions. What should come next?
4, 16.
Look at this.
Or 5, 16.
5. 2, 3, 4, 5. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. Okay, is this arithmetic or geometric?
It's geometric.
Okay. It's kind of strange, isn't it? Because you're adding here and you're multiplying there, you know. Okay. All right, now then it says to, to draw a pattern with 6 points on there and figure out, what it would be. Okay, if we did 6, how many would it be over here?
32.
Right, okay. We're not going to do that though, okay. You got enough to do in a minute. Okay, to number 10, I've had this for years and nobody could figure it out. And I don't even know what the answer to it is, so we're skipping 10. All right, let's look at 11. All right, determine the pattern that exists and write the next probable number. State whether the given list of numbers forms an arithmetic or geometric progression or neither.
22.
Okay, and how did you get that?
Just because it says 2, 7, 12, 17.
Mm-hmm. What's the difference? 5. Okay, you're adding 5. That's right. Even though you didn't know what you were doing, you had it right.
My brain had it back. My subconscious.
Right.
Is O the last vowel in the line of vowels? Like Z would be the last consonant?
Mm-hmm.
Unless you do Y.
I don't know. Okay.
I don't know why I keep looking at
Okay.
that.
All right. Well, you can work on that. Okay. What do you think the next one's going to be? This one.
112?
Nope. Yes, very good. Okay. What you're doing is multiplying each one by 1/3. A third of 3 is 1. A third of 1 is a third. 1/3 times 1/3 is 1/9. 1/3 times 1/9 is 1/27. Good.
You got 18 and I got 1.
Okay.
So we're on your tail now.
Now, was that arithmetic or geometric?
Do what? What was that?
Was that arithmetic or geometric? This one? Geometric, because you were multiplying. Okay, let's look at this one.
54.
Okay, let's see. All right, now, anybody have any idea how he got that?
Add 6 the first time, add 8 the second time, add 10 the second time, 12, then 14, the next one will be 16, the next one will be 18.
Good. See, if you can't figure out what they're adding to each other, you know, you can try multiplying, you can try dividing, you can try subtracting, and then you can also try the difference. And so that's what was going on here. The difference between 4 and 10 was 6. From 10 to 18 was 8. 18 to 28 was 10. 28 to 40 was 12. And so, and this is 6, 8, 10, 12, 14. That one was harder, wasn't it? Okay. 14. You'll probably get this one pretty quickly.
I think you overestimated our capability.
No, just think about 181. What do you think it'll be, David? You have any ideas yet? Okay, look at this. What's square root of 144? 12 times 12 is 144.
12 times 11,
Mm-hmm.
12 times 10.
Mm-hmm. Not 12 times, but the square root of.
Oh, that's right, yeah. I don't know.
So, what's 7? 7 times 7 is 49. Okay, so that'll go in there. Okay, now 15 is an important one right here. I'll let you think about it for a minute.
Says 1 and 1 makes 2, and 2 and 1 makes 3, and
Uh-huh.
2 makes 5.
Mm-hmm. And 5 and 3
5
is
makes
8.
8.
Okay. That is called the Fibonacci sequence. Fibonacci sequence.
You
I
can spell
think.
that for me.
F-I.
Sounds like a dish of rice.
Sure. I was going to see if it was in here anywhere. It should be, if it isn't. It's really important in science and math. But I can't find it in this book. I guess it was in the last one. We may come across it later. Okay, so anyway, that's
I'll
the,
spell it how it sounds.
right. But it's a guy named Fibonacci, and so he did that.
Spell
Okay.
Fibonacci sequence.
Fibonacci. I have no clue. I can't spell.
So it's Italian?
And that's not the way you spell it. But we'll find that later. Okay, look at number 16. If you notice on the bottom, it's 2, 3, so the next one would be a 4. And that's called like the square root of x, the cube root of x, the fourth root of x. So, and then so the next one would be 5th. Like that. Okay, next one's pretty easy. Okay. So you got a 5, and then it'd be parentheses 1 plus 1 over 5. Right. Okay. All right. That's enough on that. Okay. Now, what we're going to do, let's see, 1 through 18 all. And then we're going to do, let's see, 19 through 33 odds, and also do number 41 and 43. Okay, and this is on lesson 1.1. It's 1 through 18 all, and then 19 through 33 odds, and this is on lesson 1.1. Remember, the answers are in the back, and if I were you, I would put a piece of paper or something back there so that you can check your answers. But try first and then check.
On number 1A, how far are you want us to go? It says list the natural numbers. You just want to just write a couple of them and then put the ellipsis.
Mm-hmm. Exactly. Mm-hmm. This is what we had here. 1 through 18 all, 19 through 33 odds, and then 41 and 43.